Now look at the definition. First, Fourier series. If f of x is a periodic function with period p is equal to L with the interval c to c plus 12, then Fourier series can be expressed as in terms of sine and cosine series, and that is we have f of x is equal a0 by 2 plus summation starting from 1 to infinite and cos n pi by L x plus bn sin n pi x divided by L. A0 is nothing but 1 divided by L, but here given interval is what? C to c plus 12, so we represent integration starting from c to c plus 12 fx dx. What about an? An is equal 1 divided by L integration c to c plus 12 fx into cos n pi divided by L x dx, and the same for bn, but cos is replaced by sine, so we get 1 divided by L c to c plus 12 fx into sine n pi x by L dx. So these are known as Fourier coefficient. If we assume that the same formula for p is equal, that is the 2 pi, but already we have noted formula for the p is equal to L. So what we are going to consider, compare with the 12 is equal to pi. What was the exactly our interval? C to c plus 12. So in that case given interval is what? That is 0 to what exactly? That is 2 pi. So we can say that the lower limit is that is 0 and upper limit is going to be what? That is a 2 pi. But how we can say that the p is equal to L? So upper limit minus lower limit, that is going to be length, and length is what exactly? 2 pi. So from this we can conclude that L is equal what exactly? Pi. So whenever we consider formula, so in that case what we can write? So f of x is equal a0 by 2 plus summation starting from 1 to infinite and cos n pi x divided by L. This was the given formula. So sine n pi x divided by L. But if I put L is equal pi here, so what it is going to be? Pi is there here, also pi is there. Pi will be cancelled out. We get a0 by 2 summation starting from 1 to infinite and cos nx plus bn sin nx. Here a0 will be what? But initially what we have seen, 1 divided by L c to c plus 12 fx into dx. But L is nothing but here pi, so we have lower limit that is 0, upper limit 2 pi, so our formula will be this one. And what about the an? So 1 divided by L, but L is equal pi, lower limit that is 0, upper limit 2 pi, f of x, and here we have cos n pi x divided by L, but L is equal pi, so pi will be cancelled out and we will get only cos nx into dx. And similarly for bn is equal 1 divided by pi integration that is 0 to 2 pi f of x into sin n pi x divided by pi, so we get sin nx dx. And these are the Fourier coefficient whenever given the interval p is equal to pi. So our formula will be this one, and based on that we can consider a0, an as well as bn. Now let's look at the first counter example. Suppose you have given that the limit -1 to +1, so in that case how we can find the formula? So in that case general formula is that whenever we consider these type of intervals, so we always compare with standard form. P is equal to L and length is what? Upper limit that is 1 minus this is the lower limit, so minus minus plus, so we get that is 2, so we compare with 2, so what we are going to get? L is equal 1. But now when we replace L is equal 1, so it is going to be what exactly like that. So this is what exactly our Fourier series. and in that case what we can assume that a is 0. So 1 divided by L, but integration c to c plus 12, that is our standard formula. But when we replace L is equal 1, so we are going to get 1 divided by 1, lower limit is minus 1, upper limit is plus 1, and function whatever it is, and then dx. And the same for an, 1 divided by L, but L is equal 1, lower limit minus 1, upper limit plus 1, and here function f of x is that cos n pi x divided by L, but L is nothing but 1, and then dx. And similarly you can find dn is equal integration minus 1 to plus 1 fx into sin n pi x and dx, and that will be the formula. And now you can integrate, but question arises that what and how we can integrate this one. So let's have a look at the first counter example. So here first question says find the Fourier series of the function f of x is equal x with the interval that is 0 to 2 pi. So already I have said you we have the general period p is equal to L. So what we can assume that the period for this interval 2 pi minus 0, so it is going to be only 2 pi. So from this what we can assume that L is equal pi, and lower limit is that is 0, upper limit is 2 pi. So here formula will be what? I am not going to remember a different formula, but you can remember standard formula. A0 by 2 plus summation starting from 1 to infinite an cos n pi divided by L. I just write first formula and then I am just explain you what we can eliminate here. Sin n pi x divided by L is there. But here L is equal pi. If I supposed to put here L is equal pi, so what it will be? Pi will be eliminated, and we get the formula only. Cos nx is there, here only sin nx is there, and that will be the what exactly our formula. So in that case what we have to determine a0, an and bl. Now let's have a first look formula 1 divided by L. What was our standard formula? A0 is equal 1 divided by L integration c to c plus 2L fx into dx. So this is our standard formula. So now just put L is equal pi, so 1 divided by pi, integration that is lower limit is that is 0, upper limit is 2 pi, so 0 to 2 pi fx dx. Now let's have a look at the integration part, but here given that function f of x is equal only x. So here integration will be what? So integration will be x square by 2 over where to where, that is 0 to 2 pi. But when you simplify, so x is equal to pi, so what you are going to get? 2 pi square divided by 2 minus x is equal 0, that is going to be 0. But when you simplify here, so what we are going to get? 4 pi square divided by 2 minus 0. So 2 is going to be cancelled out, 1 pi is going to be cancelled out, and we get a0 is equal, that is 2 pi. Now let's have a look at the an. 1 divided by pi, integration that is 0 to 2 pi x cos nx dx. But what was our standard formula? An is equal 1 divided by L c to c plus 12 fx into cos n pi x by L dx. But if I put here L is equal pi, so what we are going to get? Cos nx, but function is what exactly? X is there, lower limit is 0, upper limit is 2 pi, and L is equal pi is there, so we get this one. Now we have to integrate, so for that I have to choose u and v. I am just taking u is equal x because its derivative is going to be what? Reducing. So therefore we assume that u, so when we assume that Leibniz rules, so x is there, integration of cos that is the sin nx, and coefficient of x that is n, so divide by n, then derivative of x that is 1, integration of sin that is minus cos nx divide by n, but 1 n is there, so we can say n square, then derivative of 1 is going to be 0, so we stop it over where to where, that is 0 to 2 pi. Now I am just going to put first one limit, so for that purpose I just use curly bracket and then I use first bracket minus then, and again I will use square bracket. So first if I supposed to put x is equal to pi, here if I put x is equal to pi, so what I am just going to get? 2 pi into sine 2n pi divided by n, and here minus minus plus cos 2n pi divided by n square, and minus, if I supposed to put x is equal 0, so this is going to be what? Exactly 0, so I put here 0. Minus minus plus and cos 0, I represent first cos 0 divided by n square. So as we know that sine 2n pi, and that is going to be always 0, cos 2n pi is always 1, and here if I say cos 0, and cos 0 is what? 1, and sine 0 is 0. So if I consider sine 2n pi, so it is going to be 0, so this term will be cancelled out. Cos 2n pi will be what? Exactly only 1, so 1 divided by n square minus cos 0 is equal 1, and 1 divided by n square, again this is going to be cancelled out, so what we are going to get? An is equal only 0. Now let's have a look at the Bn. Formula will be same, but cos is replaced by sine, and that is our Bn. So 1 divided by pi, function is what? Exactly only x, and this is sine nx dx. So this is our u and this is v. So 1 divided by pi is there. First I keep u as it is because we are using Leibniz rule, and integration of sine, that is minus cos nx divided by n, minus derivative of x, that is 1, integration of minus cos nx divided by n, so it is going to be minus is there, so sin nx divided by n, but also 1 n is there, so we can say n square, and derivative of 1 is what? That is 0, that means we have to stop it. But if I consider upper limit first, so what I am just going to get? Cos 2n pi, and cos 2n pi is what? Exactly 1. So minus 1 divided by n, and just put here x is equal to pi. Minus minus plus, and sine 2n pi, and sine 2n pi is what? Exactly 0. Minus, if I consider this value, so x is equal 0 is there, so I'm just going to get 0, and sine 0 is what? That is 0. That means when we simplify, so our answer is going to be minus 2 pi divided by n, and 1 by pi is there, but when we simplify, so we get minus 2 by n. So our Fourier series is given by, this is our considered Fourier series, and if I replace a0 by 2 pi, an is equal, that is 0, and bn is equal minus 2 by n, so we get the final answer. So this is our required Fourier series. Thank you.